Hi everyone, I'm Alicia Skiver-Palmer.
Sorry. Thank you.
Everyone gets it wrong. For my internship project, I decided to build a dashboard specifically for storm chasers. I wanted to create something that brought the tools and weather data a chaser actually needs into one place instead of constantly jumping between different websites and products. So for the development process, I used Cursor and ChatGPT, where Cursor handled the coding and the development, while I used ChatGPT mainly for research and for helping me turn my ideas into detailed prompts for Cursor. I had a pretty specific vision for what I wanted the dashboard to do. So a lot of the process was building something, testing it, figuring out what wasn't working, and then refining it from there. One of the biggest challenges with building this was knowing when the output was actually right. Sometimes it was extremely obvious, like my first attempt at extracting the surface fronts, which basically looked like someone scribbled on the map with crayons. And then the first UT attempt, which if you know how to read it, was obvious. But other times it wasn't obvious at all. My SKUT actually looked pretty good, convincing after the second generation, but when I started validating the values, they were completely off. That became a really important part of this project. Just because data looks good on the screen doesn't mean it's correct. I still had to understand the meteorology well enough to question the output and then validate it against trusted sources and then just know when something didn't make sense. The overall goal was to just take all of these different pieces of weather data and bring them together into one dashboard that can actually support a chase decision. So StormPointer includes SPC products, meso-analysis, surface features and observations, radar and satellite, model guidance, point forecasts, soundings, hotographs, routing, and then there's the storm chaser score. I'm not going to go through every single feature, but I wanted to show some of the main ones and how they work together throughout the chase process. I wanted real-time observation to be easily accessible within the dashboard, so I included severe weather reports, surface station plots, and MEDAR observations. The storm reports are interactive, so I can click on a few reports, for example, hail and thunderstorm, wind gusts, to see details. Surface station plots give a broader view of the conditions across the area, and then the MEDAR stations can be selected individually to pull up the actual observation for that location. And this just gives the chaser several different ways to see what conditions are actually being observed in that area. So one of my ideas was to be able to visually connect what we're seeing on radar with some of the mechanisms that can contribute to lift. So first we can see the surface low in this area. I can click directly on it, identify exactly what feature it is. Pulling these surface features was one of the hardest parts of the project because I had to consistently compare it against the official analysis to make sure the positions were correct. And then we can identify the stationary front and then the trough that's just to the south. Both of these are important because boundaries and troughs can create areas of convergence and provide the lift needed for storm development. You can see if I followed it up further south, northeast, there was another part of stormy weather that followed that stationary front. You can also overlay the SPC1 outlook, and you can see in the same area that there's a moderate risk for weather. So instead of looking at each of the products separately, you can start visually connecting the entire setup right here in the map. I also brought the SPC products directly into the dashboard so you can quickly move through day one, day two, and then day three convective outlooks to see both the current and future severe weather risks. We can view individual hazards like tornado risk, and then you can switch to an area of hail potential, wind potential. Moving down, you can also click on mesoscale discussions and click directly on the highlighted area to pull up the details of that discussion to see what meteorologists are saying. Severe thunderstorm warnings also work the same way. So clicking on the individual warning brings up the details for that specific storm. And then you can look at other warnings nearby as well. And all these products don't have to be viewed one at a time. You can layer the products and see the outlooks, the discussions, the warnings, and any other SPC information all on the map at once. And then satellite and radar are both really important for watching how severe weather setup actually evolves. So the simulated reflectivity gives us a look at where the model expects precipitations. And then the water vapor gives us as a much broader look at moisture in the mid and upper atmosphere. So you can identify like dry air, moisture transport. And then the geocolor gives us a more natural view during the daytime, which makes it easier to see cloud cover and watch areas of developing convection. Infrared is good is useful because it works for both day and night and uses cloud top temperatures. So those colder cloud tops can help identify stronger convection and rapidly developing thunderstorms. And just by having these products together, we can move from what the models expected to what the atmosphere is actually doing to what is developing on the radar. The meso-analysis product lets us look at some of the actual ingredients that could make some of these storms severe. So starting with thermodynamics, the 0 to 3 kilometer lapse rate shows how quickly temperatures are decreasing in the lower part of the atmosphere. Steeper lapse rates can support stronger low-level instability in updrafts. We can move through the different runs to see how environment's changing. We can look at surface-based CAPE and SIN just to give us a look at the instability on surface-based storms. And then I also have kinematics built in here as well to show like bulk shear and how much the wind changes throughout the atmosphere. It helps us assess whether storms could be organized. Storm relative helicity gives a better idea of potential rotating updrafts. And then at 850 millibars, we can look at lower level wind field to see how the winds are expected to evolve with each run. And then we have composite indices. The 0 to 3 kilometer EHI combines instability and helicity to highlight environments that may be more supportive of rotating storms. And then I've got the significant tornado parameter, which brings several of these ingredients together to show areas where the overall environment may be more favorable for stronger tornadoes. So we can move through the different runs through all of these toggable layers and just watch how that potential changes over time. Those are just a few that I showed. There's a lot that you can toggle through thermodynamics and kinematics. The point forecast lets me compare several different forecast models for one specific location. Starting with the HER, you can look at hourly forecasts, and then you can switch to NAM and then change the variables to like temperature. You can move to GFS and look at specific forecasted wind gusts and quickly scroll through how those values are changing over time. Below the dashboard, I wanted to summarize the model comparison so that way you can see where the strongest agreement is and the biggest differences are. You can switch to NBM and look at something completely different like the CAPE. And just being able to compare models and variables this way is important because you don't want to rely on just one model alone. It gives a quick way to see where there's confidence in the forecast and how the environment at that specific location is expected to change. The sounding section generates on location sounding details. So a user can quickly pull up a full SKU-T. They can view a hodograph and then they can look through calculated sounding parameters. I also created a quick look at some of the important severe weather parameters that was, I don't know why the video is not playing, but this feature was one of the more complicated features to develop because I had to use Anaconda and build a separate Python service using MetPy to process the atmospheric data and then calculate the parameters and generate the SKU-T and the hodograph to then be displayed back into the dashboard while I consistently checked for accuracy. Looks like it's frozen. Oh, there we go. So the storm chaser score is where a lot of the data starts coming together. So we've got the score for the current conditions as well as best chase window and when that occurs. So the current score takes into account the SPC risk, the thermodynamics, the kinematics, composite indices, radar, warning and reports, and even chase logistics, and the same thing for the best chase windows. We can also switch to click on the targets tab. You can compare other locations that might have higher scores. That might represent a better chase target. So rather than replacing the chaser's decision, the score is meant to quickly bring all of those different factors together and help point them towards areas worth investigating further. So once we have a target, we can move into the routing section. So the dashboard calculates the route to that location. And once we view the route, we can start the chase directly from the map. And then once that route is active, we can see any warnings that could impact us along the way, where they're located along the route, how far they are, and how long it'll take to reach them. And then the safety tab takes that a little bit further. So we can see the conditions at our current location along with conditions ahead of the route, which I have categorized in clear, advisory, caution, or warning. If conditions become unsafe, I also built an escape route feature that, when fully implemented, would help direct the chaser away from the hazardous area. And then further down, there are safety guidelines specific to the type of storm at that destination, including what to do, what to avoid while chasing it. All of this uses the chaser's live location, so we can see the GPS is online and continuously know where we are in relation to the route and the hazards around us. So how does wet dog weather fit into all of this? One of the biggest advantages is the amount of weather data they have available and how easy it is to visualize. So all of these toggable layers add another piece of the chase environment. So temperature and moisture helps us see changing air masses and boundaries. The cloud cover can show where we're getting more or less heating. Surface winds help us see changes in wind direction, and visibility is obviously important once you're actually out chasing. Even smoke can matter because thick smoke can limit heating, which can also affect how storms develop, and it can also reduce visibility for a chaser. And this is really only just the small portion of the data wet dog weather has available. So being able to access and visualize so many different types of weather data gave me a lot of options when deciding what would actually be useful and to include in the StormPointer. And it just adds another level of situational awareness to the dashboard. And that is it. That is StormPointer Chase Command Center.
Thank you so much for your presentation, Alicia. I did put in the chat that if anyone has questions, we'd love to do a short Q&A after each presenter. So I do have one question that I wanted to start with is what inspired you to build the StormPointer, and who do you see as your users that would be most likely to use this?
So I absolutely love severe thunderstorms and tornadoes. Although I've never seen a tornado, I've gone tornado chasing a couple times. And I've been in the situation where I've got an iPad and my phone and a second iPad where I'm just kind of pulling up everything as I go. And normally I have my brother with me. We both go, and he's driving while I read the data and explain where we should go. It's just really difficult to have all those tabs open all at once and trying to read everything all at once, and just being able to see everything layered on top, I figured would be very useful. And then I thought, well, I could use this opportunity to develop something. So I see the main users being, storm chasers who hopefully are meteorologists as well, and can read that data and be able to easily access that data just in one dashboard or platform.
Great. So if you had another month, what kind of things would you work on in StormPoint to add to StormPointer?
So right now the GPS routing feature is functional and it works. I do want to add on top of that, like any road closures, because it'd be a terrible situation to be storm chasing and then be stuck at an area where a bridge is closed or there's some construction that the map did not foresee. I have to still figure out like how to input that, just because I can imagine I'd have to somehow get some kind of data from every county's, Department of Transportation. And I'm not sure how, in depth that goes. So it's just going to be more research and more trial and error just to see, how I can fit that in there to make sure that it's safe also and not just drives you into uncertainty.
And what's your feature that you're most proud of, and why is that?
I would say the sounding. I know the video wasn't working, but maybe it'll work. Oh, there we go. So the sounding part. So generating the SQT and the hotographs definitely took a lot of trial and error, and I had to use other applications. So like Anaconda, and I had discovered MetPy, which I never knew that, all of this was generated using Python, and that meteorology has their own specific Python usage. And so learning that, I was actually pretty impressed with myself being able to have that on location generated SQT and sounding. I know a lot of places have like actual observation, but weather balloons aren't launched everywhere and they're not launched regularly. So it's really hard to get that upper atmospheric look. These are based off of her, so they are, modeled, but I was pretty impressed with being able to have that displayed in the dashboard. And they are accurate because I did compare them against actual sources from, I think, Pivotal Weather and other websites.
Wonderful. And so David had a question about data looking good doesn't necessarily mean it's correct. So how do you know that the data is truly correct and not just looking good? And I think you sort of answered that, but go ahead and
Yeah, so I like the second time I generated this QT, I was like, oh my gosh, that actually looks really good. And then I did compare it to Pivotal Weather was one place that or in Tropical Tidbits, I think was another place, and I put them side by side, and it wasn't correct. Like the wind shear was off, the cape was off, so there was just something with the calculations or the Python coding that was just off. So it was just revisiting, going back to Cursor, saying, "Hey, this is off," and having honestly Cursor figure it out. And then the next time I brought them up, the same. I had to copy the longitude and latitude to the Pivotal Weather one, so I got the exact same area. And yeah, they were almost identical. And I know some places use different models, so there are going to be some offages. They're not going to be exact, but they were very minimal.
great. And we had a question from Tom about if you are planning on actually launching StormPointer for university or government teams that may be out there chasing storms.
Asking if I'm going to?
Yeah, or what if you're planning on supporting this further?
I mean, that would be fun. I was really into this project just because I love meteorology and I love all the data and just, again, being able to view it all in one spot versus having multiple different tabs and you can layer them on top of each other. I mean, it would be awesome, obviously, to see it used in a public or governmental situation. If I continue to grow it, it might be something that I'd pursue further or, launch in an iPad app or something like that. I don't think it'd be beneficial on a phone, but something that someone can mount to their dashboard as they're actively chasing that has, goes off of cell towers or something like that. It would be really cool to see in use.
Yeah, and there was a question about whether it would be useful for storms at sea or ships near ports. And I'll let you opine on that.
There were some times where I did click out into the ocean. I know some of the surface features do include Canada and parts of the ocean. And then I know Wet Dog Weather's data also includes parts of the ocean too. I don't think any of the SPC mesoanalysis stuff includes the ocean. I think that's just the United States. It'll be a little bit difficult because there really isn't a whole lot of data out there. But again, that would just be more research.
Great. Well, I'm going to cut our question period a little short and